All right, I think we're good to get started. This is just a background information on some of our panelists, some of the technologies that we'll be speaking about super briefly today, and some of the reports that I may be mentioning in some of my questions today, and all around just some good information on the on hydrogen, on the importance of carbon capture, and on the global energy trends of energy efficiency. That one's really interesting. I would highly recommend you watch that one and the webinars associated with it. So just on the agenda for today, we'll start with Mark's presentation before going into just a general chat with all three of our panelists. I'll stop sharing this. Brilliant. All right. Well, thank you everyone for coming to part 3 of our 4-part series called Grounded. My name is Alex and I am the chair of the Monash Energy Club and will be today's host for the webinar. This webinar today focuses on future energy technologies that are breaking ground in Australia, or in some cases have been rolling out over the past few years. These are technologies that you'll be seeing a lot in the coming years, and hopefully will be changing our energy grid for the better and mitigating climate change. Ben, I'll get you to turn your camera off just 1 second as well. Thanks. So I'll introduce our panelists. Just when I call out your name, if you could raise your hand, just because I can't point to you. So that'd be a good way of making sure there's a face to a name. So I'll start with Mark Twidell. Mark is the Director of Energy at Tesla. Mark has had a 20-year career in solar energy from BP, the Clean Energy Finance Corporation, Clean Energy Council, and for the last 4.5 years has been at Tesla. Tesla Energy made headlines in Australia after Elon's tweet that a large-scale battery could be built in South Australia in 100 days or their money back, which, as you know, they did successfully. And now Tesla also provides Tesla Powerwalls, which are small-scale, home-scale batteries to store solar power. And eventually, not in Australia, I don't think at the moment, but their Tesla Solar Roof will hopefully come eventually. Next is Neil Kavanagh. Neil Kavanagh is the Chief Scientist at Woodside Energy, where he's been for the last 16 years. Prior to Woodside, Neil spent 17 years at Shell. So clearly Neil chooses his employers carefully and appreciates some good tenure. Woodside has been heavily investigating the role of blue and green hydrogen and how they can work together to decarbonise Australia's gas industry and linking this with an export industry to South Korea and Japan. Lastly, we have Paul Webley. Paul is the director of the Woodside Monash Energy Partnership, which was launched last year. This partnership aims to accelerate transformational research in carbon neutral technologies and shape next generation leadership that will enable a lower carbon energy future. Woodside and the partnership have been great supporters of the Monash Energy Club in 2020. And Paul is also a Monash professor in chemical engineering and holds executive positions in clean energy technology, consulting companies, and has a PhD in chemical engineering from MIT. Now, as with the previous webinars, there will be a big element of audience participation in these webinars. So we ask that you use the Q&A function, which you can probably see, to ask all your questions. Oh, sorry, I'm just getting some chats. Sorry. Yeah, so please use the Q&A function rather than the chat. You can use the chat function to chat with the other attendees, but we won't be looking at those for questions. So you can vote and comment on your favorite ones, and you'll then be given permission to unmute yourself and ask your question directly. If you prefer to stay muted, then let that be known in the question, and one of our team members will ask it on your behalf. Please keep the questions relevant to each panelist and the topic they are discussing. And then without further ado, we'll hand over to Mark, and Mark will begin with a presentation on some of the work that Tesla's doing in an Australian context. So Mark, I'll hand over to you.
Thanks, Alex. Yeah, hi everyone. I hope you can hear me okay. I will now share my screen and let me know if you can see a Tesla presentation.
Yeah, looks good, Mark.
Good, okay. So you should be able to see the title there, Innovating Battery Storage. I thought maybe just give you just a general update on how we at Tesla are seeing battery storage and what's coming, and that might then lead the way to what I hope will be an interesting discussion, which Paul and Neil will take more of a lead role in. But the various different fuel and energy transition opportunities and technologies that are available to us. Maybe from the outset, I think it's assuming that the bulk of the 90 or so people I'm speaking to, assuming the bulk of you are kind of pursuing interests in energy into the future, I just think it's an absolute wonderful time to be going out into the world. There is just so many different lines of opportunity available. None of them wrong, all of them right, as we go through this sort of once in a century energy transition that's underway. So first thing I'd just like to speak about is Tesla's mission, which is to accelerate the world's transition to sustainable energy. I worked at BP for almost 20 years before I had 4 or 5 years with the Australian government, and then 3 or 4 years working with a German solar inverter company, SMA. And in all of those previous organizations where I worked, and the mission statement might have changed once every 4 or 5 years. I don't know if the organization really knew what the mission statement was, but very much at Tesla, you can pretty much go up to any of the 50,000 employees, wherever they are, whatever they're doing, and ask them what the mission statement is, and I can pretty much promise they'll tell you it, and also what they think their role in is it. So it really is a kind of binding force. That it's a mission statement that I'm sure is shared by many organizations, but as you go forward and choose your pathways and what you want to do, I think really thinking about the mission statement of the organization that you're joining and how you can contribute to it is a really, should not underestimate the importance of that. And then we know why that is. That's due to the very rapid uptake of carbon intensity in the atmosphere at the moment. So perhaps just a little bit of an insight into Tesla. Our CEO, one of our founders, Elon Musk, when the company first started almost 12, 14 years ago, wrote out a very simple master plan. And the first version of that was to build a sports car, which was known as the Tesla Roadster. That would attract a number of customers, as it proved to be, who were willing to invest in a high cost, high value car. That generated sufficient confidence in the company and sufficient investment numbers to build a more affordable car, but still quite expensive. So Model S, Model X were, in Australian dollar terms, $150,000, $200,000 motor vehicles, still, way out of reach of most of us. But that created a customer base of tens and hundreds of thousands. And from there, build a highly affordable car, which is the Model 3, and that still needs to come down in cost and price to be more affordable generally. But just a very simple plan. That strategy was kind of updated 3 or 4 years ago when I joined to transition more to being from a Tesla Motors company to a Tesla energy company. So solar and battery storage being a key part of the theme, expanding vehicle product lines, and then moving into technology and full self-driving being a theme. But I want to, in this presentation, I'll talk about the role of software and technology in battery storage. And my role at Tesla is very much on the things that don't move. So as Alex said, batteries for people's homes, power walls, batteries for utility power plants, and then and also managing the service and all of the software that comes to make all of that come together. Oh, beg your pardon. So how do we go about achieving that mission? Try and think about it in very simple terms. To address the world's carbon emission challenges, Tesla's chosen 2 sectors to focus on: transportation and then the electricity sector. So clean generation enabled by storage can then reach individual stationary applications, and through transport we can help address the carbon emissions from the transport session. So it really is a kind of mission orientated how statement. And how is the company going? So making quite an impact now on vehicles. You can see very much at the moment limited to a smaller number of OECD countries, probably about 1 million vehicles now on the road. That's just an absolute tiny percentage of the world's overall annual, market for vehicles. We're seeing many companies now moving towards EVs. We're seeing Volkswagen, we're seeing Daimler Chrysler announcing that all of their R&D in future is going to be towards, EV drive chains. I'm sure we'll hear from others later about the opportunities for fuel cells and hydrogen propulsion. So it really is a big transition in the world's transport sector, of which Tesla is focusing on electric vehicles. Then the other big piece that Tesla's focused on is enabling charging networks. So the darker blue colors there, or the lighter blue colors, are the various different networks of supercharging that has been opened up around the world. If you buy an EV, one of the first questions you tend to ask, or even before you buy it, is, well, if I want to go on a trip, how will I charge it? So a big part of Tesla's strategy has been to build out charging networks. And then residential deployments, so you can see the orange, where our Powerwall programs are now starting to reach. So there's over 100,000 Powerwall customers now around the world. And I think some of the interesting things to note about, residential deployment is we start to move away from the major cities. So if we look at Australia, you can start to see that the orange being where our Powerwall fleet is deployed, very much following the population centres. Same in New Zealand, same you can see in Europe. Sort of spread down from southern Italy. So whilst vehicle customers might be more congregated around some of the major centres, our Powerwall customer base is much wider. And then these yellow dots are where we've been deploying commercial systems, so island microgrids, large utility power plants similar to the Hornsdale battery that Alex mentioned, but I'll speak about it a little. So from a technology perspective, let's start with the home. And I think everyone can sort of understand that solar energy, rooftop energy is really gathering pace. We've probably got 30% of homes in Australia now with solar electricity with solar panels on their roof. That percentage is much lower in many other countries, but it's growing very quickly. And increasingly people want to take control of their energy use, not just during the day when the sun's shining, but also be able to use that energy at night. So batteries provide them with that opportunity. But it's very much an underutilized resource. If each individual home just puts solar panels on their roof, a battery on their wall, and then doesn't interconnect or interact with others in the grid. So a big part of the technology evolution at the moment, or revolution, is the creation of what we call virtual power plants, where through software services, all of the individual solar and battery systems can be aggregated and coordinated as a block. So if energy market prices are high, batteries can discharge. If energy market prices are low, and we see increasingly during the day now that electricity prices almost go negative because of so much solar energy on the day, then batteries can charge. And those batteries can, stabilize the grid, can help lower the costs of the whole community rather than just the individual with the battery. So big trend towards the role of software, predictive algorithms. Another big opportunity is, and we're starting to see, is island nations moving from previously being reliant on 100% diesel to very, very quickly transitioning to 90–95% renewables. This slide here is an example from Samoa, where linking together some wind generation, solar generation, small hydro plants, and diesel generators as backup for long periods of poor weather. And you can control all of those resources together. Again, the role of software. Starting to see very quickly these island communities can move, driven primarily by economics, from expensive, high-cost imported diesel fuel through to very high percentages of renewables. So that's an interesting development that we're working on closely. So globally, operating in over 30 countries now, starting to see hundreds of these island microgrid projects emerge, moving into the hundreds of thousands of residential batteries. We measure storage deployment in gigawatt hours. So Tesla would have deployed about 3 gigawatt hours, 3 to 4 gigawatt hours of storage now. Still very small numbers compared to what the potential of the future world's energy market needs are, but still very much at the beginning. and starting to have a major impact on vehicles. So, over 1 million vehicles deployed now, growing quite quickly. So in Australia, some of the projects that I might just share with you, Hornsdale Power Reserve, so that is the big battery in South Australia. Just a little bit of background for that might be of interest. When we started up the energy program, the Tesla energy program in Australia about 4.5, 5 years ago when I joined the company, a lot of people knew about power walls and batteries, but really didn't know a lot about how batteries might work for utility power plants. We'd go and we'd knock on the door of the utilities, so we'd go and speak to AGL, Origin, the transmission companies, Electronet in South Australia, and all interested in batteries, but the common answer would be, well, can we install a few hundred kilowatts? Can we install a megawatt? Can we watch it for 4 or 5 years? Can we get confidence with the technology? And we were really looking at this mission about accelerating the transition to sustainable energy. So when in September 2016, South Australia had a major storm went through, you might have seen the pictures. Perhaps some of you were living in Adelaide at the time. Major storm went through South Australia and literally ripped down transmission lines. A various set of events happened, which resulted in the state losing electricity for 6 to 7 hours. System black, it was called, and it led to a big national debate about what was the cause of that. But we did a bit of research at Tesla, and we realized that had there been a 100 megawatt battery in South Australia at the time, that, when we took advice from a couple of engineering consultant firms, had that 100 megawatt batteries been there, the interconnector, which is the transmission line between Victoria and South Australia at Hayward, that with all likelihood wouldn't have overloaded. And if that hadn't overloaded, then it wouldn't have disconnected. And if that hadn't disconnected, then the chain of events that led to the system black wouldn't happen. So we just made the statement that we thought 100 megawatt battery could be quite effective in avoiding these problems in the future. And indeed, these batteries could be built very quickly. We just finished a project in California where in 100 days we'd had to build a large battery for Southern California Edison to replace a gas peaker plant that wasn't available at short notice. So we knew these things could be done quickly, and that kind of led to this global interest in this idea that if you didn't build it in 100 days, it would be free. Had a big project team, they built it, and it's since been operating quite successfully and is now been expanded to 150 megawatts. So the idea there being that the path that you're often on when you're speaking to incumbents is that they like to do things slowly, they like to try things, come back in 5 years' time, let someone else do something big. And this sequence of events allowed us in Australia to kind of quickly move from kilowatt scale batteries to hundreds of megawatt scale batteries. And that has been part of a trend globally. So in the US now, we're seeing similar size projects being built at scale. Solar and storage now looking like it's competing on an economic basis with gas peaking plants. And so that's just a little bit of a background on that project. We've also got a project in South Australia, which we call the South Australian Virtual Power Plant, installing solar and power walls in the homes of housing trust tenants. So South Australia's perhaps got 40,000 people that live in government-owned housing. People that have often been unlucky in life, and for them, saving money on electricity is really, really important. So this project aims to both show that we can lower the cost of electricity, we can deliver carbon-free emission reduction, and we can also improve grid reliability through the virtual power plant, through some of the software that I was talking about earlier. So a couple of examples of projects we're working on. What's next? Really just starting to see scale ramping up. So we are already seeing renewables plus storage starting to replace gas and coal generation in terms of new generation. Huge role, I think, for other fuel technologies, and I'm sure we hear about that from our friends from Woodside shortly. And then importantly, for those of you who are thinking about future careers, the role of software, the role of how you do all of this stuff, how you predict it, how you optimize, how you bid electricity into markets. You may have heard about blockchain technologies, you may have heard about machine learning techniques. The pace of innovation at the moment in the software platforms and how that leads to economic opportunities and physical opportunities in the market is all really, really exciting. So all of that has an effect on economics. So scale drives down cost. So just as what happened with solar PV, when you start to manufacture things at millions of quantity in factories, you can drive down the cost, you can improve the process reliability, and that's what's happening with battery storage. These factories just producing millions upon millions of small battery cells which get linked together in products and can be deployed quickly and cost effectively. How you then link all of those things together with software and really focus on trying to create benefit for customers. So really, in Australia, we really are and can kind of lead the way in this mission statement, to accelerate the world's transition to sustainable energy. And really encourage you all to, pursue your interests in energy, to keep an open mind about technologies, because the future is always going to be different than you think. Really look to embrace the transition that's going on. So, Alex, I'll stop there now, switch off my screen. I hope some of that was of interest and move more into discussion.
Brilliant. Thank you so much, Mark. We've already got a few questions in the Q&A, so we'll try and take around 10 minutes of questions. We don't have too much time, unfortunately, but we'll just take a few questions. So I'll hand over to Ben or Faisal to unmute and select some questions. If you're there, Ben and Faisal.
So I'm going to unmute Daniel. He has a question, if that's okay.
Cool, thanks, Daniel.
Yeah. Yeah.
You there, Daniel?
Are you there?
I think I can read Daniel's question. Is that?
Yeah, all right, maybe we'll just read it out.
Is Tesla working on anything to utilize batteries inside their cars to provide similar stabilization? And what's the state of the technology? So that might be talking about what you might call vehicle to grid technology. So the idea being that at the moment, at least from a Tesla perspective, electric vehicles, the flow of energy is from the grid to the vehicle, but not from the vehicle back to the grid. So, currently from Tesla's perspective, the view and the experience with our customers is they like their vehicles to be fully charged when they go to drive them. So the potential disruption to the customer experience about having your vehicle being used for purposes other than driving is something that is a customer inconvenience. So it's more a customer decision rather than a technology decision. Is the technology available so that you can have bi-directional inverters and have cars feeding back into the grid? Absolutely. And Nissan with their Leaf car are doing trials globally. I think what we might start to see is when car ownership moves from individual across the fleet. So if you think about large fleets of people having electric vehicles or electric buses, then generating new revenue streams to make them more affordable or make the investment better is going to be really important. So perhaps when electric vehicles move towards being fleet ownership, we might see more bi-directional vehicle to grid technology, but the technology is there. It's really just how the customer experiences it that is the short-term issue.
Right. All right. Thanks, Mark. Might jump to Roger Dargaville. Might have asked this question for him. Why is Powerwall so uptake so high in Italy? Do they hate their energy providers, or?
Yeah, I don't know if there's any people Italians or Italian heritage on the thing. So I think what we find in all of our markets at the moment is it's very much an early adopter market. People liking to take control of their energy use. And certainly we see within the Italian market strong desire for people to, for individual action. I think there are probably some Italian incentives there, and electricity prices are high. So it's been those combination of factors.
All right, thank you. I might just ask one quick question. You mentioned that Hornsdale is a virtual power plant or enabling a virtual power plant in South Australia. What's sort of the scale of that technology? Like, can we see that grow in scale to cover large areas of Australia or all of Australia? Is that possible?
Yeah, I mean, it's certainly possible. For those of you that follow the electricity market may have seen some recent, and it's an interesting document to read, the Australian Energy Market Operator called AEMO. A few weeks ago, maybe a month ago now, launched what they call their integrated system plan. So it's a series of kind of scenarios about how Australia's electricity needs might be met in the future. And they look at central scenarios, which are kind of business as normal. And then they looked at a distributed energy scenario. And there they saw virtual power plants going from, today, literally a few megawatts of generation. And if you think about the Australian electricity market, there's probably 40 or 50 gigawatts of total generation fleet around the country. And in their distributed energy scenario, the AEMO predict that virtual power plants, so distributed storage and solar, could grow to being 18 to 20 gigawatts by 2035, 2040. Which would be, and that as the growth of virtual power plants almost follows the decline of as coal generation exits. So it's certainly a technology scenario that's real. How the future evolves, I think, it remains to be seen. But I'm sure the role of hydrogen and some of the things that our friends from Woodside might want to talk about will kind of broaden the discussion up a bit.
All right, thank you. Well, I'll start to move the discussion towards our other panelists. And I think a good bridging question here would be, is hydrogen, which is a big focus of Woodside, is that a competitor with batteries, or are they sort of competing for two different niches? And are they solving two different problems in our energy grid? So I'll chuck that one to Neil, if you don't mind starting, Neil.
Hey, thanks very much, Alex, and thanks, Mark. Hello, everybody. It's great to be here. I always love being at Monash, where Woodside has the Woodside Monash Energy Partnership and the Future Lab. But on the question of hydrogen, obviously it's an energy vector to the extent that you can transport hydrogen, and it's a fantastic chemical battery, so it can store energy. So what's distinctive, I suppose, about hydrogen is the scale of the energy storage that is possible in a volume of hydrogen held in a pipeline, for example, which is kind of unlimited, which is not the case for most of the battery technologies today, which have a sort of manufacturing scale to them, with the possible exception of pumped hydro, which again is a sort of natural energy store, isn't it? But it's also the case that hydrogen's quite costly to store. So I think very quickly with hydrogen, you probably find some sort of economic limit on the volume of storage that you can have there. It's also got some limitations as a vector. We contemplate compressed hydrogen gas storage, liquid cryogenic hydrogen storage and transport, but also in the form of ammonia, or even for that matter, using methane, synthetic methane as a sort of hydrogen carrier. Both methane and ammonia are a lot easier to pump and liquefy and ship. So I do think that they're complementary rather than alternatives, and they have different features. I can also tell you that making green hydrogen requires having access to a battery. If you're going to make renewable power through electrolysis into hydrogen, it's quite a costly electrolysis plant, and it needs to run 24 hours a day, 7 days a week. So you need to have nighttime storage if you're relying on solar and or wind. Quite possibly it could be electrical storage, but it could also equally possibly be thermal energy storage, because the reactions that we're trying to drive are endothermic in the case of the reforming reaction anyway.
Great. And Mark, would you comment on, would you agree that you think hydrogen batteries are complementary? Oh, sorry, you muted, Mark. I might just in the meantime. Then I might jump to Paul and ask Paul the same question. Paul's got a background in hydrogen energy. What are your thoughts on the complementarianism on hydrogen and batteries?
Yeah, look, Alex, they're absolutely complementary. So, you know, the big differences, of course, are around scale, both with respect to size, but also with respect to timing. So there's this concept of seasonal storage, right? So if we do have a increasingly large fraction of renewables, which we all hope we will have going ahead, then we can expect to see not just day and night, but also seasonal variations, and using batteries at a seasonal level currently might be very expensive. No one has a crystal ball, so we don't know what batteries are going to be like in 2030, 2040, 2050. But extrapolating from what they are now, it's difficult to see from a seasonal standpoint how that will work. But that's really where hydrogen comes in. So I think they're very, very complementary. You know, if I was going to drive my little car in and out of town every day, and yes, one day we will be able to get out of lockdown and drive around again, then I would absolutely see that as being an electric vehicle, because batteries make perfect sense for that. But if I'm going to drive my train across Australia from one end to the other, I don't want to be waiting hours and hours to recharge the battery. So I'm going to have hydrogen storage. So they're complementary. They're perfectly complementary in my view.
Great, thank you.
Sorry,
Mark's back.
Yeah, at some point in life you'll realize you're not very good with technology. Yeah, no, I totally agree. I mean, what I was saying was the world needs all the clean energy it can get, and it uses a lot of energy. So I spent, before I joined Tesla, and the last job I spent some time with the Australian Solar Institute, really looking at the opportunity for Australia's. I mean, the other thing to remember, and I'm sure our colleagues at Woodside will talk about it, Australia's just got this huge supply chain already, of energy supply chain to the world. So whether it be natural gas going up to North Asia, and so the opportunity to start to lighten those fuels, and for, you know, hydrogen to come in as syngas or ammonia, as as Paul mentioned. Also really interested in the idea of, fertilizers. There's a lot of, ammonia and hydrogen that goes into fertilizer content. So thinking about energy intensive products and how hydrogen can lower the carbon intensity there. And I was listening last week to a podcast where Ross Gittins, eminent economist, was talking about, the opportunity in Australia has got to generate hydrogen incredibly cheaply. So much renewable resources available in the long term. So exporting, hydrogen generated steel, all sorts of, supply chains open up when you think about the advantage Australia is going to have to generate hydrogen effectively, and how can you transport it in a way that's cost effective. So really exciting. Don't I see it entirely complementary. There's always going to be competing at the edges, but that's what technologies do.
Yeah. And how are we expecting to see this export of hydrogen grow? It's a big focus of Woodside at the moment. Is this going to replace or displace our coal industry, our coal export industry, I mean?
If I may answer that, I think it's definitely going to become, post-2050, the predominant form of energy export. I wouldn't 100% write off any particular form of energy, fossil fuel energy, or for that matter, biomass, because there's a number of pathways into hydrogen that use things like coal and biomass. And really the question is, which is the most economic way of producing and exporting hydrogen? But what I will say is that I see Australia being a continued energy exporter into the future. And what I would really like to see, and I'm so happy to say this in front of all the Monash students and staff, is that we want Australia to be a knowledge and technology exporter, as well as a kilowatt hours exporter. We want the techniques and the technology and the methods to be homegrown and used to export our natural renewable energy resource. Rather than simply be the country that's got the sunshine and the wind, lucky break, but then have to import all of that technology from overseas. And if we're smart, we'll do what we've been doing, I think, with liquefied natural gas, which is really build up some Australian capability. The other thing is that, like Mark just said, we actually also export a lot of energy-intensive raw materials, you know, principally metals. And it would be great if we could process those ores here in Australia. I would love to see an iron ore to raw steel plant built in the Australian Pilbara, you know, running off of solar power and wind, and then exporting sort of semi-finished steel for finishing in Japan and Korea and China. I think that would be just marvelous. Mm. And when I look ahead to the next 25 years, that's what I'm really betting on, is that Australia becomes the smart country, which has also got these marvelous raw materials, and we get 2 shots at goal.
Brilliant. All right, thanks, Neil. I might just pivot the conversation a little bit. Stick with hydrogen a little bit and gas. We've heard a lot about the future of energy sort of being electrified and moving into a sort of state where gas is being replaced through renewables and through electricity. And this was actually a topic that was brought up in our first webinar, and some panelists were a proponent for electrifying Australia. I might chuck to Paul. Is this an actual viable possibility to electrify all of Australia and remove gas completely from the equation?
Thanks, Alex. That's a really good question. And, you know, again, no one has a crystal ball. We don't know what 2050 and 2100 looks like. But let's just, you know, I'm an engineer, so I work with numbers. So let's just look at the numbers, right? So we consume energy in Australia. We consume that in the form of electricity, and we consume it in the form of oil and transport and gas and heating and so on and so forth. And if you look at the relative amounts, so I'm going to give you some numbers. We consumed last year about 6,000 petajoules of energy. Now, what the heck is a petajoule? A petajoule is what about 40,000 households use a year for energy. So it's a lot of energy, a petajoule. And Australia consumes 6,000 petajoules. Of that, 6% was renewable energy. And of that, 3%, so half of that, 3% of the total amount of energy was solar and wind. So we use far more energy in gas than we do in electricity. So a lot of it comes as a surprise to a lot of people when we're all focusing on decarbonizing electricity, but we use more energy as gas than we do as electricity. So if we want to remove all of the fossil fuels, and it's not just gas, it's oil, it's coal. If we want to remove all of that, we're going to have to take our wind and solar and multiply them by a factor of 70. But we don't have infinite time to do this. You might say, well, okay, that doesn't sound too bad. We can do that over 50, 100 years. We don't have 50 or 100 years. We've got to do things by 2050. So from a purely scale point of view, it's just impractical. But probably more importantly is it's not something that, you know, we're looking to decarbonize. We're not looking to electrify, we're looking to decarbonize. Electrify is one way of decarbonizing. And it's absolutely the way we should use where it makes sense to do it. So for example, transport for little cars. Let's run EV vehicles right now. Let's start down that path. Let's build it up. Let's build up the renewable energy base as we are. Let's build up the electric cars as we hopefully will start to do. So low-hanging fruit. So there are absolutely areas where we should be running and electrifying. But there's a much easier and a much cheaper way to decarbonize a lot of our fossil fuel. For example, gas. We could convert the gas to hydrogen. We could decarbonize by increasingly putting hydrogen into our pipeline. And if we make that hydrogen, and we'll talk a little bit later about green hydrogen, then that again comes back to having to put more renewable energy in. But if we make that with blue hydrogen, that gives us a chance to ramp up really quickly and make a large amount of hydrogen quite quickly, and at the same time add value to our current exports as well. So I think it's completely impractical really to say we're going to electrify everything. We've got some applications, by the way, that are very hard to electrify. For example, really high temperature heating in industry is currently done with gas, very hard to do that electrically. but you could potentially do it with hydrogen. You know, when last did you fly on an electric-powered airplane, and will you fly on one? Maybe not soon. So fuels have got this wonderful thing that they're very, very dense form of energy. And there's some applications are just extremely hard and extremely expensive to electrify. And you're much better off decarbonizing using other methods. So, so I guess that's how I would sort of respond to that question, Alex.
Cheers. Thank you, Paul. And on that question, there's a similar question in the Q&A. What's limiting this growth? And I know you don't have a crystal ball, so, but what is sort of a realistic target or a realistic type of scale of decarbonisation through gas and through hydrogen in the future?
Boy, yeah, as you say, I don't have a crystal ball. I think there's, you know, you have to kind of have a mission, right? You have to have a goal in mind. And a lot of countries have declared net zero carbon by 2050. If you look at the latest Shell Sky scenarios, they have painted pictures of economies transitioning by 2070 to net zero. By the way, those transitions don't have zero uses of gas and oil. They still have quite a substantial component of fossil fuels, but they're still net zero. So I would say, you know, reasonably, if you looked at, and again, it was mentioned earlier, AEMO's ISPs was announced recently, how they looked that we could transition. We could potentially certainly transition from more than, at the moment we have 20% solar in our electrical energy supply system. Maybe we can transition to 30, 40, 50%. I know AEMO thinks that by 2040, half of our energy generated in Australia will actually be the customer generating energy through solar energy, which is very, very interesting. How you manage a grid where the customer you are selling power to is actually generating a lot of your energy. So, so I think it's doable that we could double or triple by 2030, 2040 what we have in place, or maybe even tenfold. And I think at the same time, if we really want to get a move on, we have to look at decarbonizing gas and oil and transport, so on, using other techniques. And I think 2050 is difficult, but we need a target and we need a mission to reach that target.
Neil?
Yeah. I just wanted to, you know, speak up for the voice of business for a minute, which is that we can transform everything tomorrow if the products that we sell, the low carbon products that we sell, offer the customer a better experience and they cost less than what they replace. When we achieve that, then we control everything. And when we don't control that and we offer an inferior experience and it costs more money, then we've reached the limits of our influence. And then we need regulation and other factors, regulation and or customer preference to be changed so that inferior product, in fact, is relished because it has other benefits. But the thing that I'm excited about working with Monash and working with Paul and with other industries like at Tesla is that in private enterprise, if we really go for it, and for example, if we can export hydrogen to Japan for less than $2,000 a ton, then normal Japanese business will just transition from methane into hydrogen, and the world will change. And if you look at all the energy changes that have taken place in past years, whether it was switching over from sail-powered ships to coal-fired ships, or from coal-fired ships into oil-fired ships, they were all voluntary transitions in which the new product was better than the old one. It was more convenient, it was more abundant, and very quickly it was the same price or cheaper.
Cheers, thanks, Neil. From the aspect of customers and improving on what we have now, I think that relates quite a lot to energy efficiency, which is something that I've found being an important topic, but one that doesn't get as much attention as perhaps it should. So, for example, the International Energy Agency released their analysis last year, which showed that we're slowing down in our improvement of energy efficiency, and that all the effort we're putting in technical advances is actually being squashed by increased human consumption, more severe weather events, meaning more heating and cooling, and that people are starting to use more area per person. So I might come back to you, Neil, and to see, is energy efficiency something that Australia in particular has been lagging on, or is it something that we really need to be giving a lot more attention to?
I think we should give more attention to it. It's the low-hanging fruit, and everyone benefits from saving money. At Woodside, we have a 5% energy efficiency target, which we're well on track to meet by the end of this year, and we're a big energy user. But of course, the energy that we don't need to generate, we can instead sell it as product. Also, I'm very proud of the Monash faculty building for engineering and IT that's going to be opened this year. It's in operation already. It's known as the Woodside Building for Technology Design, and it's the first building in the Southern Hemisphere, commercial building, to have the passive house design. So the architects tell me it's like living in a thermos flask. Nothing gets in, nothing gets out that they didn't intend to get in or out in terms of energy, and therefore it just consumes less per person. But it's not really like living in a thermos flask. It's a marvelous architect designed experience, and that's what we want. So I think that energy efficiency can be cool. And just on a personal note, I think also it means more getting on your bicycle and cycling to uni. It means enjoying using public transport, enjoying sharing your car with other people, and having a smaller home.
Yeah, thank you. Mark, I think energy efficiency is incredibly important when you're talking about batteries and you're talking about solar. What sort of improvements would you like to see in this field, or what is Tesla doing in this regard?
Yeah, no, energy efficiency is everything if you've got a certain amount of energy and you need to go as far as possible. So I think one of the things with electric vehicles is it's really driven some of the technology changes in making inverters more efficient, thinking about car tires, thinking about aerodynamics of vehicles. So that's all kind of energy efficiency in the propulsion of a vehicle. In terms of energy efficiency and electricity at people's homes, I think the next wave of innovation is going to be around being able to tell if somebody has plugged in an electrical appliance that might not be working very well, or it might be inefficient, because you can start to monitor people's electrical patterns and give them advice on how they can use less. So if it comes to winter time and you start to see large squares appearing that looks like someone's plugging in electric bar heaters, then maybe letting them know that there's actually different technologies available at lower cost, and ultimately selling people a service. And I think to Neil's point, the future will happen because things get better, not because there's mandatory change. So energy efficiency, if we can make it easier for people to do things, heat their water in more efficient ways, have swimming pool pumps that only operate when the sun's shining during the day, charging your vehicle when the prices are negative because wind and solar are available. It's not just energy efficiency, but also utilization efficiency, making sure that electricity networks, at the moment, they're probably only used at peak capacity for less than 0.1% of time per year. How can we use them more efficiently as well? So efficiency generally across the economy is going to be a huge thing in this transition.
Cheers, thank you. Just coming off the back of what we can do, there's a question by Alex Vollerberg that I'd like to get asked. So for Salah Bin, we could unmute Alex and have him ask his question, please.
Yep, I'm unmuting him right now.
Thank you.
Yeah.
Go ahead, Alex.
Hello, yep, perfect, sorry.
Yep.
So my question to the panel is, as a soon-to-be graduate engineer, I graduate end of this year from La Trobe, I am really, this is my biggest interest is getting us to net zero and a circular economy and a sustainable economy. Where would you suggest I focus my attention to hopefully have the biggest impact in actually getting us there? Cheers.
I'll jump to Paul for that, as he's the Monash professor.
Thanks, Alex, for putting me on the spot as the first one there. Look, I think it's tremendous, Alex, that that's that you want to do, that you know, you're passionate about the net zero activity. There's a wide range of areas I think that you could look at if one is passionate about getting us to net zero. So obviously, the energy industry, whether it's finance, I'm not sure what your background is, as you say, graduate engineer. So there's a lot of good engineering companies. Woodside is one that are looking at how do we decarbonize. How do we, you know, most of the big companies have internal targets, and so getting involved in those activities, getting involved. There's almost any level you could go into, political level, industrial level. I think it's really a very rapidly growing area. There are also things I would suggest that, you know, if you graduate. There's particular areas of our industry where you don't have skills in at the moment. So there's additional postgraduate training. Doing a PhD with me would be a fantastic idea to get into how do we really solve this very complex problem. So I guess the thing to emphasize here is these are not easy things to do. It's easy for us to sit here and make glib statements about what should happen. These are very complex. Energy system is very complex. And getting a more in-depth look at and a more in-depth analysis with a company. And I would emphasize that if you do a PhD, I think you should do it along with a company embedded in an industry that you can really have impacts. Industry is really good at deploying things quickly and steering and helping, making sure you have impact. So I think that's certainly an option. To some extent, it depends on whether you're anxious to go out and get a job right now, whether you're prepared to put in a little bit more effort and get a more complex set of tools that will allow you to do that. So I hope that's sort of giving you some sort of idea, but in terms of the area, it's as broad as you wish to go into.
Cheers, thanks, Paul. I think, Mark, would you be able to discuss maybe some of the niches that you think are opening up in the energy industry that an engineer such as Alex could get into?
Yeah. I mean, pick what you're interested in and go hard at it. I think, you know, the sort of net zero is the mission, but the strategy is how do you get there, and there's just going to be so many different pathways. So, Alex, I don't know what type of engineer that you are or where you want to go to, but increasingly just the role of optimization and software and thinking about forecasting of needs and how you can make markets more efficient by the utilization of resources seems to be a huge opportunity. So whether that's forecasting what energy is going to be required at a particular moment in time in the future and making sure it's available to be dispatched, or looking at how you schedule resources in a manufacturing supply chain so that you can increasingly use energy when it's available. I think one of the big things that's going to happen into the future is that energy is going to be better to use at some times of the day or sometimes of the season than others. So Paul spoke about seasonal storage. So you think about demand being variable. I think more and more we'll start to think about electricity supply being variable as well. And how do we use our engineering talents to increase variable supply with variable demand? And yeah, follow your passion.
Cheers, thanks, Mark. Now, there's one more technology I would like to discuss today, and that's carbon capture and storage and utilization. I'll get Paul's thoughts on this because I know it is a topic that the Woodside Monash Energy Partnership is covering. In the IPCC report, they stress in the 1.5 degree report and the 5th assessment report that carbon capture is going to be something that we're going to have in our emissions pathways. However, they say that the technology has stagnated from the time it was published in 2015. I'd be interested to know, would you agree that it's stagnated? Has there been much change in that technology? And if so, or if not, what can be done through the Monash Energy Partnership, perhaps, to advance this technology?
Yeah, Alex, thanks. It is interesting. I've been involved in carbon capture and storage for about 20 years now at an R&D level. And look, it's evolved from consideration in the 1990s through to initial deployment. Some of you may not be old enough to remember, but I'm sure you all saw pictures of Kevin Rudd standing up and announcing 20 carbon capture and storage plants by 2020. So if you look at where CCS is now, carbon capture and storage, so there's actually over 50 carbon capture and storage plants around the world. So it's one of those quiet, I wouldn't say success stories, but it's one of those quiet achievers that people are just building capture plants and putting them in place and capturing CO2. So at the moment, we're storing over 40 million tons per annum of CO2 are being stored by carbon capture and storage plants. So it's actually working, it's in place. And I think what's happened over the last, since 2015 is we went from a lot of activity to R&D, deployment, and now we're in the phase of any technology where the technology works fine. But we're learning, we're doing the cost reduction by doing, learning by doing phase of the technology, which means that you deploy the plants, you run them, you find problems, you make, which you couldn't find through R&D because you weren't doing it at scale in R&D, and you're understanding how to set up the business models, how to set up the technology models for the next one. So for example, the cost of the first CCS plant that was about 6 or 7 years ago has come down by about a factor of 2. So it's now, instead of $100 US dollars a ton, it's now around 40 to 50 US dollars a ton. Of course, it varies widely depending on many, many factors, but by and large, the cost has come dramatically, and it's come by learning by doing. At the same time that that's progressing, the R&D has shifted focus to, on the one hand, really blue sky ideas for 2040, 2050 and beyond for CCS. And on the other hand, it's also shifted to doing what I would call troubleshooting R&D. So, you know, what are the things that happened in the carbon capture plant that we didn't expect? And what R&D do we need to do to overcome that? So I wouldn't say it's stagnated. I'd say it's reached a phase where there are more plants than ever are on the drawing board and are being put in. And so the IPCC is absolutely right. It's CCS went from it would be nice to have to it would be really nice to have to we absolutely need it. And now what's perhaps even a little worrying in the IPCC report is the reliance on CCS to say we actually need negative emissions. So we need to take biomass, burn it, capture the CO2 and store it so that we have a negative emission. So we actually have a flow of carbon from the atmosphere to the ground. And it's increasingly relying on CCS to give us this negative growth, which is making people in the CCS area very nervous because, you know, while that's certainly possible, that's a long way from economic at the moment. So CCS is at the phase where it's still expensive to do. It's cheaper than the alternatives at the moment, and it's in the R&D phase of learning by doing. But I think it is something that it will have to accelerate. It's nowhere near the level that it has to be at if we have to meet our 1.5 degree targets. It needs to ramp up dramatically. So, but it's here to stay. It's not something that's going to go away. There's a lot of industry that releases CO2 that is inherent in the process. That you have no choice but to do CCS. You can't just electrify it because, for example, the cement industry releases CO2 as part of the product. You have to do something with that CO2. Now we're looking with Woodside at a path of converting the CO2 into something useful. And for those of you interested in that sort of technology, I would encourage you to contact me and Neil and have that discussion, because that's a really, really interesting angle of instead of just sequestering the CO2, can we actually convert it into something useful, something marketable, and create some value from it? So I might just leave it there, but it's definitely something that's here to stay, I think, in at least the short to long term. But,
Great, thank you. All right, Neil, are we seeing CCS then beginning to play a part maybe in Woodside's operations in any extent?
Yeah, 100%. We already biosequester the reservoir CO2 coming off the Pluto reservoir, and it's the largest carbon abatement scheme in Australia into forestry, effectively into soil carbon, and that's the low-hanging fruit really in Australia, is to regenerate some of the some of the clearings that we did at the sort of turn of the last century and put it back into forestry. And we're very, very busy with that. I don't know if everyone knows, but you can offset in Australia your emissions in the by acquiring Australian carbon credit units, ACCUs, and these these cost somewhere between $10 and $50 a ton to create. So Woodside is very busy at the moment trying to create an abundant and affordable source of these to offset further our reservoir CO2 emissions at the LNG plant. In addition, when we talk about exporting ammonia and blue ammonia, which is made from hydrogen, and blue ammonia in particular generates a lot of CO2 in making that hydrogen, we want to geosequester that CO2. And one of the simplest places to put it is back into the reservoir from which the methane originated. So we're busy with that. I think that will be one of the earliest large-scale CCS schemes that you see in Australia. Chevron already operates the Barrow Island geosequestration scheme, which is a very large geosequestration. And it goes back into an old oil field because not everybody wants to have CO2 pumped underneath their local paddock or CO2 pumped underneath their house. Whilst in theory, there's nothing wrong with it. A lot of people would say, yeah, that's great, but could you put it somewhere else? So putting it back into an old oil and gas field doesn't have those sorts of issues. We're currently looking at a field in, which I won't name, but it's a world-class gas reservoir on the border of Australia. And we're curious to see if we couldn't export carbon neutral fuel from it and geosequester the CO2 that's associated with it, or create biological credits so that we can sell the LNG that's already offset. So it's a carbon neutral LNG product.
Okay, brilliant. And what sort of challenges would you like to see be solved by the Woodside partnership in terms of CCS, I mean?
CCS ultimately is disposing of a waste product in a passive and useless format. I find it deeply unsatisfying as an engineer. My idea of being an engineer is to create valuable products that help society. So my ideal sequestration methodology is either not to emit CO2 by making carbon neutral fuels, or to sequester them into products that don't reach the atmosphere but are nonetheless useful. A good example is soil carbon, which improves the fertility of the soil for farming. Another good example is to make products that are derived from the carbon. For example, recyclable plastics would be a good example that didn't enter the atmosphere but nonetheless provided you with some utility. I don't really find it very satisfactory to do underground disposal generally.
All right, cheers, thank you. I've only got one more question left, so start putting your questions in the Q&A. I don't think it's going to be too long or too big of a question. To Mark, we've seen that the federal government has a big Australian hydrogen strategy supported by a number of ministers. Do you think we'll begin to see a federal backing for battery technology in the near future?
Yeah, I mean, I think Australia's got such a kind of wonderful history in the export of liquid fuels and gas fuels that it kind of makes logical sense to leverage all of that supply chain and capability that exists already. So I can understand why chief scientists, the Australian government, very much focused on the hydrogen opportunity, because unless we do something about that, big source of emissions from all of those fuels, we're not going to do it. So no problem at all with the focus. I think the federal government probably is supporting batteries in many ways. So the Hornsdale expansion battery that I mentioned before, that benefited from a grant from the Australian Renewable Energy Agency, so that the battery can start to demonstrate what's called fast frequency response or inertia response. Inertia being the physical requirement for electricity frequencies to stay stable during changes. So when large rotating gas turbines or steam engines, when those big bits of metal are going round at so many thousand RPM, that the mechanical inertia provides frequency support and stability. So we've got Australian government support in supporting that. So Alex, look, I think that batteries are being supported. You know, when you're in a particular sector, you always like to see more, but I think the other thing is just the pace of change that's going on globally. I think any new technology innovation that at its root has got mass production. So factories just making things in their millions at increasingly lower costs. That's just a huge, you know, transformation effect. So yeah, I think batteries are, whatever the Australian government does, batteries are probably going to be propelled globally at quite a rate.
Cheers, thank you. Now there is a follow-up question by Daniel. I'm not sure, I might just read it out for him. So following up on the idea of virtual power plants, it seems like achieving energy sustainability is a very complex optimization problem involving lots of data. Obviously, Tesla has a very strong data science capability as demonstrated by Autopilot. Is Tesla looking into big data solutions to help solve the optimal use of virtual power plants? And is this capability currently available in Australia?
Yeah, yeah, kind of Autopilot is the software platform that Tesla's developed for its car fleet, so they can automatically make choices about whether to stop, whether to drive ahead, and ultimately, you know, lead to, you know, potentially robo-taxis and, you know, the vehicles without the need for a human behind the wheel. We've also got a software platform which we call AutoBidder, which is looking at projecting what's going to happen next in the electricity markets. Is it better for the battery to discharge? Is it better to charge? What do we think the solar production is going to be in the next few minutes, in the next few hours? What do we think the person's load profile is going to be? And making those kind of optimization decisions all the time. So yeah, Alex, very much. And it's the same sets of software engineers and the same kind of capability sets that get leveraged with big data, whether that's being optimizing a fleet of vehicles or optimizing a fleet of stationary batteries.
I'd be interested to hear Woodside's take on the importance of data science and in the oil and gas industry. I know that's sort of been a bit of a focus in the Future Lab at Monash, doing a little bit of, I think, machine learning in their plants. Perhaps Neil, would you be able to talk about data science a little bit?
Yeah, what we have at Woodside in Australia is some of the largest industrial plant in the world. The replacement cost of the industrial assets that we operate is $50 billion, and it creates a rich data science opportunity to optimize that plant for the purpose of basically eliminating failures and unplanned shutdowns. So we're going through a massive sensorization of that plant at the moment with low-cost sensors running off LoRaWAN Wi-Fi networks. We've even been designing our own sort of low-cost sensors, little magnetic devices with a vibration and a temperature and an acoustic receiver built into them. They have to be encapsulated so that they're suitable for a gas atmosphere as well, so that they're safe. But anyway, it presents a marvelous data science opportunity for the purpose of increasing production and reducing costs. We don't have so much of a retail or consumer orientated opportunity, because remember that Woodside is a ultra large scale energy exporter. So we export to other countries who import, and they have the consumer relationship. So sadly, we don't really get to see so many of the ordinary families, mums and dads, everyday people in China and Korea and Japan that consume our Australian products. But when I do go to those countries, it's always a pleasure to find out that there are real people on the end of the pipe, and that they appreciate having a warm house and a hot shower and you know, cooking something nice for dinner. But we're not really connected. When I was just recently in China, just before the shutdown though, and we were talking about something that is very interesting, which is when you do combined heat and power and you use a solid oxide fuel cell to make in your building block heat and electricity, you get a record 90% energy extraction out of the methane, and therefore you get more useful kilowatt hours per CO2 emissions, so that you drop the effective emissions to something like 300 grams of CO2 per kilowatt hour by generating hot water as well as electricity. And I think that's a really promising urban, big city technology. And that's one of the things I would love to work on with Paul and the rest of the Monash team, is how to make next generation gas and consume it directly into combined heat and power. It's a kind of distributed power plant. So instead of the gas going to a big, enormous generation plant on the coast, you generate your own plant in your local community, your local university, for example.
All right, brilliant. Well, thank you very much, Neil. I think it's that's a good note to end on. Just like to thank Neil, Paul, and Mark again once more for agreeing to chat with Monash students. I think we had around 90 people attend today, which is brilliant. I think I think it's tied for a highest attendance. So it's great to see all that. And I will just plug once again a couple of questions in the chat about graduate positions and PhDs and internships. There is the Woodside Monash Energy Partnership PhD open now. I think international students, the deadline is tonight, but domestic students' deadline is the end of October. So many of the technologies that you've heard about today are being studied at Monash, and I would urge you to research a bit more about the Monash Energy Partnership and see what they're doing. I've also seen plenty of internship positions and job openings available at Tesla. My LinkedIn feed goes off multiple times a day about new jobs at Tesla. So I'd also urge you to check out Tesla. Thank you to Faisal and Bin, who are helping me moderate the Q&A today. And thank you to everyone who asked the question. At the end of this, there is a survey that we'd love you to fill out. It helps us plan for the next webinars. And I would also like to address that this webinar and the previous webinar were all male. It was all male panel. And I do think it's very valuable that we do hear from females in energy. Unfortunately, it's a symptom of the industry, I think. We do get in contact as best as we can with a lot of female professionals, but sometimes it doesn't work out. But that is something that we will try and improve on, and we will work on in future webinars and throughout the year, trying to get more of a female presence and female representation. I will lastly just share our next webinar, which is on energy investment and finance. So we'll be hearing from the Clean Energy Finance Corporation, as well as Frontier Economics. Frontier Economics helped the Turnbull government, I believe, in a lot of their energy planning, and you'll probably know the Clean Energy Finance Corporation. So I'll also put the link for that in the chat just now. There you go. That's a sign up for the next webinar. Hope to see you then. This will be our final webinar in our grounded series. But yeah, I'll leave it there. Thank you very much again to Neil, Paul, and Mark, Bin, and Faisal. All right, thank you. I'll see you all later.
Thank you very much indeed, Alex. Thanks, everyone.